The first problem that was asked for was number 33. 33 says P is the point -2, -1. Q is the point 6, -2. And it says write V as a vector in the AI plus BJ position vector. And so P is the terminal. This is the end. No, Q is the end and P is the initial. So it goes from here to there. So how much did it move in the X? It went from -2 to 6, so that's +8 in the X direction, which is the I vector. And then it went from -1 to -2, so that's -1 in the J vector direction. That's it. That's all there is to those. Next one is 36. And it's 36 says do the same thing here. P this time is 1, 1, and Q is 2, 2. So this vector goes from 1 to 2, so that's 1 in the I, plus, and from 1 to 2, that's 1 in the J. Next one is 45. And 45 says find out how long the norm of V minus W. So first we got to find out what V minus W is. V is 3 in the X direction minus 5 in the Y direction. W is -2 in the X direction plus 3 in the Y direction. So if I do V minus W, if I go 3, then subtract the -2, that'd be add 2, so that'd be 7 in the X direction. And if I go V minus 5, and then I go -3, that'd be -8 in the J or Y direction. And the length of this one would be the square root of 49 plus 64. 113, square root of 113. -8 squared is 64, 7 squared is 49, 50 and 63 is 113. Now, next one is 48. And that says, what's the length of V plus the length of W? And V and W are the same. So the length of V is the square root of 9 plus 25 plus the square root of W is 4 plus 9, which is, so that's the square root of 34 plus the square root of 13. That's what those two added are. And you could do a decimal value if you want to. And then that was 48. And we're supposed to do 51. And 51, find the unit vector in the same direction as V. And V is 3 in the I direction and -4 in the J direction, the Y direction, and the X direction. So this one right now has the length of the square root of 9 plus 16, which is 5, 20, square root of 25 or 5. So this is 5 long, and we want to make it 1 long, so I just have to shrink it down. So I'm going to take and divide everything by 5. So I'm going to get 3/5 in the X direction minus 4/5 in the y direction. Now it's 1 unit long. If you don't believe me, we can show that 3/5 squared is 9/25, plus minus 4/5 squared is 16/25, and that length is the square root of 25/25, square root of 1, which is 1. It's a unit vector. It's 1 unit long. And then 54. 54 says, get a unit vector for this one. U, which is, V is 2 in the x direction, minus 1 in the y direction. So the length of this, the length of V is square root of 4 plus 1, square root of 5. So we just divide by the square root of 5. So the unit vector would be 2 over the square root of 5 in the I, or x direction, minus 1 over the square root of 5 in the j direction. And you could rationalize that, but that's good enough. You can check and see if it's actually got a length of 1, and it should. And then 75 says, find the resultant of, now here's problems that are at least a little bit interesting. 30 degrees, and the size is 40. And this one is minus 45, and the size is 60. These are newtons. So I can go this one plus this one and figure out what the result is, or I can go this one plus this one, and I can make a triangle, and I got to figure out this one. But it might be easier just to say 40 newtons at 30 degrees and 60 newtons at minus 45 degrees. And if I change them into the I and j directions, it'd be 40 cosine of that, which is 40 cosine of 30 is 34.64. And the y direction would be 40 times a half, which is 20. And this one, 60, that's going to be both times the square root of 2 over 2. 60 cosine of negative 45 is 42.243. And that's positive x and a negative y, negative 42.43. The sign of negative 45 is negative. And I add these together, and I get 76707. Here I get 43 and 62. Nope. 20 from this is 22 minus. So now I got to convert it back. So I got to go 77.07 squared plus, and I don't care about the minus, 22.43, not further squaring, 22.43 squared. Take the square root, and I got 80 Newton force at, now I got to get the angle, and it should be a little bit negative here. So that's the tangent inverse of this. So tangent inverse of negative 22.43 divided by 77.07, negative 16.22 degrees, 23 degrees. Okay, that's 75 and 78. 78 says, find the actual speed and direction of an aircraft if it's going 500 due west. So that's 500 at an angle of 180. And 78, excuse me, 500, yeah, headed due west, and a jet stream of 100 in the southeasterly. So if that's 500, 100 is much shorter. And so that's 100 at negative 45, that's southeast. And you just go through the table again. This would be in the x direction, that's negative 500, and 0 in the y. And this one is 100 times 7071 is 70.7, 71 roughly, and 71. The x would be positive, the y would be negative. Do 100 cosine of negative 45 and 100 sine of negative 45. Add these up and we get negative 430 and negative 71. So we would square those. Plus 71 squared. Take the square root. And that's 435 kilometers per hour, or whatever that was. Is that what it was? No, 100 miles per hour. And to get the angle, see if it's plane's flying this way, the wind's going this way, it would be over here that it would be going. And so that's on negative here. So I'm going to have to add 180 to whatever the cosine gets me. This is going to be negative 71 or negative 430, so the negatives are going to cancel out. I'm going to do tangent inverse of 71 divided by 430. And then add 180 because the angle, the x was negative. So it's 180, 189, 9 degrees down here, or an angle of 189 in trig, which means it's going 435 miles per hour at a heading of 9 degrees south of west. Okay, good enough. We know where it's going. And then the final one was 88. I don't know if I'm going to have enough room here. Let's see what 88 is. Oh, that's that sine one. Yeah, I'm not going to have enough room on that. That is, or the suspended weight. So we've got it suspended over here. The angle is 35 degrees, and over here it is 50 degrees, and the weight is 800 pounds. So the 800 pounds is straight down, and that's the total force. (270 degrees is straight down. It's causing a force in this rope that's at a trig angle of negative 35 degrees, and we don't know how much. It's causing a force in this one. We don't know how much, and that one's at, well, if that's 0, that's 180 plus 50 is 230. So I'll slow down here on this one a little bit. So we got to do x cosine of negative 35. Cosine doesn't care about the negative, so I just got to do cosine 35. So it's going to be 0.819x. Then the sine of negative 35, it does care. This will be a negative answer. Negative 0.574y. And now for the 230, we're going to have cosine 230 times y, which is negative 0.643y. And for this one, the sine of 230, that's also going to be negative. Negative 0.766y. And this plus this has got to equal this one. Well, 800 is not sideways, it's straight down, so it's negative 800. When I take 800 sine of 270, 800 cosine of 270 is 0. So I get this plus this has to be 0. So if I solve for y in this, I can move this over to this side and then divide it, so I get 8.819x divided by 0.643 equals y. So I added that to the other side and then divided by the 0.643 and got this for y. So I can put that into the other equation. This is x. So I got negative 0.574x minus 0.766 y, which is 0.819x over 0.643 equals negative 800. So I put this in for the y, and so I got that many x's minus that many x's equals negative 800. So I can multiply everything through by minus 1, make this look a little nicer. And so I have x's in both of these, so I can factor that out, and I get 0.574 plus this stuff, which is 0.766 times 0.819 divided by 0.643. So I've got 1.5496 or 7, 155. That's close enough. 1.55x equals 800. So 800 divided by my answer is 516. That is x. That was the force here, 516 pounds. Then I can find my y by just putting that in for x there. So I got to take it times 0.819 divided by 0.643, and I get 658. That's how much in each of the rows.